In part 6 of Further Vectors, we are going to be looking at projectile motion. But before we get into any sort of calculations, in this first video, which will be quite short, let's just get a bit of a sense for what it means for a projectile to be launched and what sort of things affect the trajectory. So let's head over to Desmos. So our regular XY axis is going to refer to the displacement of the projectile. So we're going to trace out its path. So the X direction, usually we talk about the range of a projectile, how far it goes, and then the Y direction, well, we use height often. So what affects the trajectory? Well, we have an angle at which a projectile is launched, right? And this we're going to consider in degrees. We have the velocity of the projectile, and then we have the height at which it starts. So to start with, we'll begin down at the origin, at ground level. So to start with, we've got 30 degrees and 25 meters per second. So let's see what this looks like. The projectile is fired, and we can see it trace out the parabolic arc that we would expect. Now, in terms of the formula that's being used behind the scenes, it's down here, and it might look a little bit crazy, but it's actually not that hard to derive, and we'll get there eventually. But you can see different things like the velocity and the angle involved. Now notice as well that we've got angle times by pi on 180, so that's just converting it back into radians, which is nicer in this Desmos program. We've also got 4.9. You can hazard a guess as to what that might be linked to. We've got the height as well right out the front. Because it's a negative parabola shape, this x squared at the start has a negative in front of it. And that makes sense, right? We have a negative parabola, so we have a negative x squared value. And the height, well, that's just the constant value, isn't it, at the end. We've just got it at the front here. Okay, so what happens if we start to mess around with some of the variables? Well, let's say that we keep the angle at 30 degrees, but we up the velocity, right? So let's say we go up to 35 meters per second. What would you expect is going to happen? Well, as the projectile is fired, it starts off at 30 degrees, but it's now going to go further, right, than before. And that makes sense. If we decided to keep the velocity at 35, but then reduce the angle back down to, say, 12 degrees, it makes sense that we have a much flatter projectile. And likewise, we could up the angle really high. Right, let's go 62 degrees. So it shoots off up before then returning down. It's interesting to note that for given questions, we can have different options available to us. So let's set something up. 20 meters per second is our velocity back to a 30-degree angle, say, and we see something like this. Let's stop it around there. And then let's consider another projectile. All right, so I've got a second one here, where it starts at the same spot. It might even have the same velocity, so let's say 20. I'll bring our velocity down to 20, but the angle is much higher. All right, let's see what happens here. Well, it's pretty close, right? So if I just bring the angle back a little bit, or maybe up a little bit, there we go. We can see that we have the same start and end point. So this second projectile has the same velocity, right? It's starting at the same point, but because it's fired at a much higher angle, it reaches a much higher maximum height before coming down at about the same spot. Okay, so that's something good to keep in mind as well, that sometimes we will have multiple solutions for a problem that we're trying to work out. Now, in harder problems, sometimes things are fired not from ground level, but from up higher. So let's take our parabolas away, and let's say our first parabola is actually shot from 10 meters above the ground. Now, sometimes they might be fired straight out, so at no angle, an angle of 0 degrees. So let's see what that would look like. Just half of a parabola, right? The top, the right-hand side. So our starting point is the maximum height. It will never get any higher than that because we haven't got any vertical angle. But if we do have some angle, then we can start to get this kind of effect, right? So it's fired up, it drops back down. Previously that would have been our finish point, but because we're above the ground, it keeps falling, and so the range extends a little bit further. So there's a whole different types of problems that we can experience, but the main thing is to understand that we have a negative parabolic shape. Our angle, right? Our angle affects the shape of the parabola. Our initial velocity, right, affects the shape of the parabola, and also our starting point, our height, translates our parabola up and down. Okay, that's a good place to stop, I think, for just getting a feel for what projectile motion is.